Welcome to Programming with Python session 19. Session is continuous discussion on object oriented programming, and I hope you have attended part A, and let us move ahead with the concepts of object oriented programming in this session as well. Before I move ahead, I would like to introduce our website technolearnid.com is what you see here. And if you are joining this session for the first time, I would suggest you to visit this site and get more insights about us, what courses we offer, and who we are, so on and so forth. And if you want to contact us, here there are different means mentioned, and you can contact us in any of these means. Also, we are on multiple social media platforms. I would suggest you to subscribe and be in touch with us. Most importantly, the resources page where we have the resources used in all these sessions uploaded here, and these are available for everyone for free download. So I strongly suggest you to download these resources and practice more and become better Python programmer. All right. In addition to that, I would strongly suggest you to subscribe to our YouTube channel Technolearn IT. With that, you will be getting daily quizzes on Python, and these quizzes are very short. They are less than 1 minute. They are half minute. So I would strongly suggest you to watch these till the end. And these quizzes are having the answers inbuilt. Hence, while the quiz is going on, while the question is going on, you can guess the answers, and you can validate your answers with the correct answer by the end if you watch them till end. All right. So this allows you to keep in touch with the concepts, and this would also help you to perform better in any kind of interviews where you have to appear for multiple choice and written tests. All right. With that said, let us go back and continue our discussion. All right. We already talked about class and objects. Okay. So what is a class and how do we define a class? To define a class, we have to use the keyword class. And what is a class? Class is a programming entity that holds the attributes and methods together. In other words, the data and the actions that can be performed on the data together, right? And what is init here? Init is called a constructor that is used to store the values in the objects. What is an object? Object is a variable of a class. In this example, you can see a class by name student, and whenever you create a variable of this class type, that becomes student object. Whenever an object is created, automatically the constructor is invoked behind the scenes, right? So in addition to the first argument, you need to pass all the values that you want to store in the object. And using self dot notation, we will be creating the attributes and we will be assigning the values that have been passed to this constructor to the attributes. Like this, you can have multiple methods. Init is a method, display is a method, update is a method, A method is a function which is written inside a class. A class function is nothing but a method in other words. Okay, and on line number 9, I'm creating an object. S1 is the name of the object, and this object belongs to the class student. And if you look at the number of arguments I have passed, it is 2. And if you go back to line number 2, the constructor by name underscore underscore init underscore underscore will be automatically invoked when this object comes into the scope. So self refers to S1, name will have RAM, age will be having 5 because you have explicitly passed the value for age argument. So the default value will be ignored and 5 will be considered as a value for age. And then the two attributes is what we can call name and age will be created, and the values that you pass like name will be assigned with RAM and age will be assigned with 5. If you really look at what happens when you create an object from the memory point of view, this is what happens. S1 is the name of the object. So this is the area of memory where this S1 will be stored. So you have name, which is an attribute. Where did this name come from? This name has come from the code that you have written inside the constructor self.name, indicating that you want to store an attribute or a property by name, right? And what is the value that would be copied into that? The name that you have passed, which is RAM. So RAM will be stored in name. And the second attribute is age, and the value 5 that you have passed will be assigned to age. All right. This is how S1 as an object will consume the memory for its attributes. I have created second object. Now what happens? A separate area of memory will be allocated for this object, and that is called S2, right? And this also has the same attributes, but the values of the attributes are different. So S1 has the value RAM in name, while S2, the object S2 has Shyam in the name. Similarly, age. So these two objects differ in the values of their attributes, but the attributes are exactly one and the same at this point of time. S1 has two attributes, those are name and age. S2 also has same attributes, name and age. However, the values of these attributes are different. That is what describes the state of an object. S1 has some state, S2 has a different state than S1 because the values are different. Now, using S1 and dot notation, I'm going to invoke a method which is display. Now, what happens? Control goes to the method line number 5 where this display method is defined. Now, what is a self? Self always refers to object that is used to invoke the method. In this example on line number 11, display method is invoked with object S1. Hence, self refers to S1 in this case. Coming to line number 6, self, which is nothing but S1, S1's memory, dot name. So, if you look at the memory diagram, S1 dot name refers to what value? Holds what value? RAM. So that RAM will be printed, and self dot age Again, here also self refers to S1 only. So S1 dot age, which is 5. So these two values will be printed because of line number 6. After that, control comes back to line number 12. I call the same method display, but with a different object this time. I'm calling the same method display with object S2. Now, the control from line number 12 goes back to line number 5, the place where display function or the display method is implemented, right? Now, what is self? Self refers to S2 because S2 is the object that has invoked the method display. Hence, self now refers to S2. Go to the memory location or the area of memory where S2 is stored. Now, self is S2. So S2 dot name refers to Shyam and S2 dot age refers to 7. So you can see Shyam and 7 both being printed on the screen in the output, right? And now these are nothing but instance variables. Name and age are nothing but instance variables. What is an instance? What is an object? Object is an instance of a class. Class is just a blueprint and object is an instance of a class. Once object comes into scope, once object gets some memory, within that memory, whatever is stored, those become instance variables. Okay, and these instance variables vary from or may vary from object to object. As you see, for object S2, the instance variables values are different. The values are different, but instance variables are one and the same in terms of names as well as number. Make sense? So instance variables are associated with object because object is nothing but an instance of a class. Now, in addition to these instance variables, what else we can see here? We can see some methods. Init is a method, display is a method, update is a method, right? These are the methods that you can also see in this code. However, these methods won't be repeatedly stored in each and every object. Only attributes will be stored repeatedly for each object, while the methods will be stored in some common memory which are accessible by any of the objects of that class, any of the object of that class. Hence, display function has been called by S1 sometimes and it has been called by S2 sometime, different time, right? On line number 11, you can see display method being called by S1. In that context only, self will become S1. In the context of S2 calling display, self will become S2. This is how the value of self depends on the object that you have used to call the method. And methods will not be repeatedly stored in each and every instance of the class or in each and every object. They are stored in a common area so that every object can access them and make calls to them. This is a memory diagram of instance variables and methods. Methods are also called instance methods, otherwise instance method, instance variables or instance functions. These are all one and the same. This is how the memory will be allocated. All right, now look at this diagram. Here student refers to the name of the class and pass mark, attendance, name, age. As you see here, there are certain things that have been underlined. What does it mean? I'm going to explain it in a second. Also, in the third section, we have init, display, update, and a drop. What are these? Init, display, update, and drop can be visualized as methods of that class. The name of the class is student. Student refers to the name of the class, right? Pass mark, attendance, name, age, these become attributes of that class. Okay. And the state of an object depends on the values of the attribute. And methods are these will describe the behavior of the attributes or the object. That's why these are nothing but the methods will be implemented to change the behavior or record the behavior of the entity. And whatever you see underlined, those are called class variables. So what are class variables? As you have just seen, when you create an object, automatically the control gets to the constructor of that class, and that constructor will bring some attributes into picture, and those attributes belong to each individual object. However, there could be some values or some data that is independent of the object. It doesn't belong to any object, but it is very common for every object of that class. All such things can be recorded under class itself rather than putting them into individual objects, right? So as you see here, two lines of code. I first create an object of student class, okay, and I pass two arguments. The first one is name and the second one is age. When it comes to the memory, I said pass mark and attendance are associated with every student. They don't just belong to one student, right? Pass mark. Every student has the same target of pass mark, which is 40 in this example. Every student has to maintain an attendance of 200 days. That is not specific to any object. That's not specific to any student. It is common across all the students. All such things, instead of putting in each and every object, we will just maintain them at the class level. Hence, they become class variables. Okay. Now, when you look at the memory, how the memory will be allocated for S1 now. S1 has two things. One is a name and the second one is age. Since you are just creating the object, automatically the constructor will be invoked. Okay. And that constructor will bring in two attributes into picture. One is probably name and the second one is age. So if you look at the memory diagram, this is how it would be. S1 comes into picture. It has name and age as attributes, and it has this RAM and 5 as their values, which are nothing but instance variables. And when I create the second object, the same very similar thing happens, but the memory allocation will be at a different area. Okay. And this object also has its own instance variables. And the values with those instance variables are different, right? And when you come and look at the methods, init is a method, display is a method, update is a method, and drop is a method. As I said, these methods won't be repeatedly saved in each and every object, but they will be stored in some common location so that any object can access them, right? So in the memory diagram, whatever you see there, they are not within any object, but they are available for objects to be called. Okay. And where do these class variables get stored? So these class variables will not be stored in the memory area of any object. So they are not going to be stored in S1 area, memory area, or S2 memory area, but they will be stored outside of all the objects. That means a separate memory will be allocated for such class variables. So right now you have two class variables in this example. One is a pass mark and the second one is attendance. So attendance and pass mark don't belong to any specific object, but they belong to every student. Every student has to score more than or equal to 40 marks. So that is a pass mark. Every student has to maintain attendance minimum of 200, right? All right. Now, when you look at this, how do you really implement class variables in the program? So how many class variables do you have here? How can I identify the class variables in the first place? Class variables won't be stored within the memory of objects. So they shouldn't be part of S1 and S2, but still they should be available in the memory, and that means they should be available in RAM. Okay. All right, random access memory when I say RAM. Okay, now as you can see, there are two class variables in this example. In the from the diagram, I'm telling you, one is pass mark and the second one is attendance. So to model this into your program, what you need to do is you need to just mention them. See where this statement is written. It is written on line number 2, which is independent of any object or any method, right? So it has been written outside of all the methods. These are nothing but class variables. So pass mark is one class variable, attendance is another class variable. And pass mark gets a value of 40 in the initialization, attendance gets a value of 200 in the initialization. Okay. Now, when I'm going to print s1 dot marks and s2 dot attendance, say for example s1 dot pass mark, go and look at the attributes of s1 in the memory. Does it have a variable by name or attribute by name pass mark? Really not. However, the pass mark that is available at the class level will be accessed by that object in that point at that point of time, and that shows the output as 40. Similarly, you also used S2 to gather the attendance. So remember, mark pass mark is not only associated with S1 because it is a class variable. It can be also accessed using S2 as well, like S2 dot pass mark. But both of them should get the same value unless until it's changed, because it is a class level variable, and that can be accessed by any object, and ideally each object should see the same response. Okay, but it may vary, but that's what you need to keep in mind. All right. Now when it comes to S2, the second object, using this S2 we are calling attendance. Okay. So first thing that what Python does is it just goes to the memory of S2 and it looks at all the attributes available under that object. Do you see any attribute by name attendance within the memory of S2? Really not, because the memory of S2 has only two things. One is name and the other one is age. Okay. Then it goes and looks at if there is looks for if there is any class variable available. Yes, of course, class variable is available by name attendance. And that is what it accesses, and whose value is 200 at this point of time. It will just access that and it will print the value. Okay. The next statement, you see, pass mark being a class variable, we can use the same class name itself to access it. Student dot pass mark, student dot attendance. These make very much sense because pass mark and attendance are not just associated or important for just one student or few students. They are applicable for each and every student. Hence, maintaining them at the class level makes more sense rather than maintaining them at each individual object level, right? So that is how you need to understand class variables. Okay. And let us now jump on to practical session, and I'm going to show you all these things that we have discussed so far. So what I'm going to do now is I'm going to create a new file, like create a class. Let me go with student only. Okay. And first thing is constructor. Say I pass name and age, two things, and then self dot name is equal to name. Similarly, self dot age is equal to age that comes in. Okay, this is a constructor. And let us also implement some function to print the values. I would call this as a display. Okay, and it takes self as an argument. Now you can access name and also age. Right, so this class has two methods, and you can keep adding more and more methods to this class based on your need. For now, these two are enough. All right, now I create an object to student class. I call it as S1. S1 is just object of student, and here I need to write student and use braces. Makes sense so far? So as you can see here, we have implemented the constructor and display function as well, as you can see there, right? Okay, for now keep it as it is, and what I can do here is if I if I can maintain S1, if I can maintain this indentation properly and all, then I can use S1 to call display function. Correct? Sorry. For a display function, we don't need these things. It is just a plain display function. S1 dot display. Okay. S1 dot display. Now let me run this program for you. Okay. What it expects is arguments, but I did not pass in the constructor, it seems. I'm going to correct it now. Sorry, what was error? Student init missing two required positional arguments, name and age, but we did not pass that. Okay, so let us look at this. Okay, sorry. Here, when I'm creating the object, I did not pass the values. So I need to pass the name and age. So here, let me make the name as some ROM and then age as 5 years. Okay, this should work, right? Now let us try that. Yes, you can see ROM and 5 being printed here. Who has printed that? When object has been created, constructor is invoked, then control comes back to this place when display is called. Display, and in this case, self refers to S1 because S1 is the one who has called display function or method. So self refers to S1, S1 dot name, and S1 dot name is, as you can see here, it is RAM, and S1 dot age, which is also 5, we have stored just now. So when you print back, you will be getting RAM and 5. Makes sense? So this is how you can have instance variables and you can refer to them. When it comes to class variables, that is different. We don't write them within any function or the method, but we will write them outside. Okay, outside. Outside of what? Outside of all the methods we will be writing because they are at the class level. Okay, so I will say pass marks is equal to 40. Okay, now pass marks has become class variable. All right, now if I want to print this pass marks, I can print it using the class itself because this variable belongs to the class. For that, I use print print student dot pass marks. Okay, I use student, which is a class name. Remember, I have used class name here to access the class variable. Student dot pass marks, and let us run this. You can see 40 coming out here in the output. Who has printed that? The statement that we have written here, student dot pass marks, is the one is accessing that and printing it over. Okay. All right. Now the same thing, but if I have to access it via objects, say how the object name is S1, no. So if I use object name instead of class name and call or invoke a class variable, what happens? So this is perfectly fine, no error, nothing. It should also give you the result, right? You see 240s. Sorry about that. Okay. Now you can repeat the same with S2 as well. S2 is just one instance of the class student, right? S1 is also instance of student, right? However, the pass mark is something that doesn't change between these two students. It is always same. So all such things, instead of maintaining them at the object level, we should ideally maintain them at the class level itself. So that is idea, and this is how it will be implemented. It is implemented in Java. Okay, S2 is not defined. Okay, sorry about that. So for S2, I need to create one more object by name S2. Okay, student, and say the age is 7 and the name is Ravi. Right, let's run this now. As you can see here, now we are able to access class variable using the class name, using the names of the methods. Sorry, using the names of the class variables. You are able to access the class variables using the names of the methods. Okay, S2 is the method and S1 is the method. S1 is object, S2 is also object. Using object names, you are able to access the class variables. All right, this you can run. All right, let's move on. So hope you now understand this. You have class variables which are common for each and every object, doesn't matter what object it is, but instance variables can vary from object to object, while class variables would be same among all the objects. Okay. Now take this example where we have only one class variable. What is its name? Pass mark. We have one class variable by name pass mark. Okay. Now you create an object. You have created two objects in the same statement. That is okay. So S1's name would be Ram and S1's age would be 6, which is default argument. Similarly, when it comes to S2, S2's name object 2 refers to the name Sam, and the age will also be the same 6, right? You have created two objects. Now if you use s1.passmarks and s2.passmark, what is it you get? So how Python tries to access the values is using s1. It first goes to the place where the memory is allocated for s1. Okay, fine, I know where the memory is allocated in this diagram for s1. It checks whether there is an attribute by name passmark at the class at the object level. So do you see any attribute by name passmark within the memory that is allocated for S1? Not really, it's not there, right? We have only two things that are available for S1 at this point of time, which are nothing but name and age, which are instance variables. However, passmarks is not present there. In such cases, Python gets to the class of that object. So who is the class of S1? It is student. Then it goes to the class level and it checks if there is any variable by name passmark. Yes, it is there, and that is what it accesses it, and it prints the value 40 in this context. Similarly, s2.passmark also same story. The control first gets to the memory where s2 is available, s2 is saved, okay, or s2 is available in the memory. There it checks all the attributes, but s2 also doesn't have any attribute by name passmark. It doesn't simply throw out an error, but it will then go and check whether there is anything available with this name at the class level. Yes, there is, right? Hence, it will just f2 also accesses the same pass mark that is available at class level. Okay, so if you have 100 different objects of this class, all those 100 different objects can access this same pass mark. Next, how to update these values of these class variables. Since class variables belong to the class, to update or to manipulate any of these class variables, you should ideally use class name. And but of course, there are other methods that I am going to show you without using class name. Also, you can do that. Unfortunately or fortunately, but that's not recommended. But anyways, at this point of time, I'm using the class name, which is student, to access the class variable pass mark, and I'm also updating it with 50. So far the value has been 40, and now I'm updating that 40 to 50 on line number 12, and then you see the value has been changed now, right? Look on the right hand side. So far look at the memory allocation pass mark. Right now the value is 40. The moment this statement executed, it becomes 50. All right, and then when you print s1 dot pass marks and s2 dot pass mark once again, what will s1 get? What does s1 get? S1 will just access the pass mark from class variable only because it doesn't have any attribute by name pass mark available within itself. Same story with S2. So both of these will access the class variable pass mark, and both of them will be reading or seeing 50 at this point of time because you have updated the value of the class variable. Make sense? All right. Look at this code now. Just look at the memory allocation, how the memory allocation is, and what kind of code you should write to match this expectation. Okay. You see, S1 is available in the memory, S2 is available in the memory, and you also have three methods that can be called. Okay, that can be called by any object of this class, right? Because these are methods. And there is class variable also by name pass mark. So how do you implement this pass mark? How to write it inside the class? So I just mark it as pass mark is equal to 40. Perfect. That becomes the class variable. And then you just allocate the memory for both these, both the two objects, and just create those objects and initialize them with Ram and Sam in the names. Then S1 dot pass mark refers to 40 and S2 dot pass mark refers to 40. S1 dot pass mark has been updated to 50. Okay. Interestingly, what happens you see there clearly, there is an instance variable created by name pass mark for which object? S1 object. What is your intention by making this statement? Ideally, your objective is to just update the value of pass mark, which is nothing but class variable. For that, what did you use? You have used object. What you should ideally use? You should use class name. However, since you are able to access the class variables through objects, you have attempted this. Okay. So, as I said, whenever you are trying to access something using object, it will first check if it in the same object if it is available. It is not available, then it goes to class level variables and check. So here pass mark is available within S1. You see there. Hence, when you are accessing it, it will just give you 50 but not 40. Now let us go and understand what happens for S2 at the same time. S2 dot pass mark. S2 is also competing and it is also looking for pass mark, right? In this case, what happens? First, Python looks at the memory of S2 and it checks whether there is any variable by name pass mark. There is no, nothing as such. Then it will go and check if there is any class level variable available with this name pass mark. Yes, it is available. So it will read the value of that uh, class variable, and 40 is what you see here at this point of time, and so that 40 will be printed. So finally, you can see the class variables accessed by what? Object names. So in the earlier slide, you have seen how to access the class variables using class name itself, which is most safest way. And of course, you can also access them through objects as well. And look at this code now. If you had done this s2 dot pass mark is equal to 50, what would have been happened? What would happen? What would have been happened? Tell me. If you have updated pass mark, which is a class variable, with the object s2 instead of s1, what would have happened? The pass marks attribute might have been created under s2 object, not s1 object, right? Now, if you go and print s1 dot pass mark, what will happen? Again, the same thought process. How does Python understand from where to pull the value? S1 dot pass mark. First thing it does is it just goes to the memory of S1 and it checks if there is any attribute by name pass mark. Under S1, there is no attribute by name pass mark at this point of time. So next step, it goes and checks if there is anything available at the class level. Yes, at class level, I can see some attribute called pass mark, and that is what it just makes use of. So it will be using 40 there, and s2 dot pass mark. When you look at s2, it really has an attribute by name pass mark. So that is what it reads. Okay. So on line number 11, if you look at it, s1 dot pass mark and s2 dot pass mark both will be referring to what? Both will be referring to the same value, which is available at the class level. After that, line number 12, we have updated the class variable value with one of these two objects. Okay. Then when you again look at it, s1 dot pass mark, what does it give you? S1 dot pass mark. Look at it. Under S1's memory, do you have pass mark? You don't have it. So it goes to class level and it will access 40. Make sense? And what about S2 dot pass mark? S2 is the object which has pass marks as its attribute. So it will just get the value from there, which is 50. And that's what you see there. All right. With all this said, let us go and practice this, and I'll explain you what really happened from the code point of view when you have written such kind of things. So I'm going to introduce one. Oh, sorry. Uh, yeah. Oh my God. I'm going to introduce a new file this time. Okay. Mm, I'll just create a new one. I'll new file. We'll store it. Okay, with some name. So the concept of class variables. Okay, I have a class and I need to have class level variable, which is class variable, right? So I'll just call it as count. And I store 0 inside that, and then I define the constructor. Initialization self. Okay, self comma. We pass name and also pass age. Something. And then where will you store name? You need to use self dot name is equal to name. Self dot age will be age. All right. Now let us just go and create an object now. I say yes is object. S is equal to student. Yeah. S is equal to student. You have created an object. Now using this object, what all you can access? You can access count, which is a class variable. But this is what I'm trying to avoid. But this is not the best practice, but I'm just showing you how you can do this. Similarly, being a class variable, you can access it using class name itself. Student dot count. Okay, this is not a function, just print it as it is. All right, now let us go ahead and run this. I need to save. Somewhere, oh, sorry, closing parenthesis and opening parenthesis. Okay, fine. Okay, you see both of them values zeros coming out. From where did these zeros come? Oh, sorry. Okay, so count is initialized to zero in inside the class, and who has executed this statement? So, being a class variable, you have zero initialized there, and when you are accessing this class variable by object name s dot count. Okay, this is an object here. You see s dot count, that is going to be specific to that object. While when you are accessing count using the class name, it is class level variable, and here this is just a local variable. That is the difference. Okay. So s dot count, what does it give you right now then? S dot count. S dot count also refers to the same class variable, so it gives you 0. Student dot count, yes, student dot count will also give you 0, right? So this is what class variables are. And when you update, I have just shown you how to access it, but I will also quickly show you how to update it. So for example, what is there in s dot count? I'll just run it quickly and once again show you. You have 0 at this point of time. Okay. And what if I want to update it? If I have to update, I should use what? S dot count equals to, say I want to put it as 10 and run this. Okay. So you get 0 0 here. After you have updated, let us go and print it again. So this is what is the message? Okay, save it, no problem. Okay, now you run this, you see the value coming out as 10. Why? Because you have updated the value of class variable by using an object. Okay, s is an object, no? So using s, you have referred to the value of count, which is nothing but a class variable. All right. So this is all what we have been seeing here, and what happens when you really try to update the value of a class variable using an object. The object will get its own copy of that class variable, and would that could differ from the value of class variable. So this is not the suggested way to update the class variables using objects. We should always update the class variables using class name itself. All right, look at this code now. You have two objects, and you can see the memory accordingly, what those maintain, and you have their own instance variables, each object holding two instance variables, and you have one class variable. Now you have updated with this, and a new attribute has been constructed within S2. And now you see I'm using a del operation, delete operation. When you use a delete operation, what is that I'm deleting? S2 dot pass mark. When we're deleting the S2 dot pass mark, what I'm really saying is please remove the attribute pass mark from S2. S2 is an object, remember that. So it will just remove pass marks, pass mark attribute from S2. So observe this memory diagram carefully. Now you will be seeing pass mark vanishing. That is because of the statement executed on line number 12. Now you can access the value of pass mark either by S2 or S1. In this case, you have executed it using S2, but you have already deleted that. No, you have just deleted S2 dot pass mark. So if you try to access it now after deletion, it will give you attribute or sorry, yeah, S2 dot pass mark. It is not possible to access. Sorry, there is a typo there. Once you delete that, you cannot access it using S2 because it has been gone. Sorry. The local copy you cannot access, but you still have a class level variable is there with the same name. So that is what you can see coming as 40. All right. So Python always looks or follows the hierarchy of looking for the variables or the attributes here. First thing it looks at is the object within the object itself. If it doesn't find, then it will look at the class level. Okay. All right. Now what are class methods? Okay. We have just looked at class variables and class. What are class methods? All right. Class methods are the methods that work on class variables. To put it simple. So take this example again. Have a look at this example. You have a class. You have a class variable by name count, and it is initialized to 0, and that's what you see in the memory as well. And there is a constructor which it takes and constructs two attributes, name and age. And look at this carefully. Student.count. What does this indicate? S is capital. That means the student is class name. Student.count. Okay. If you are using the notation student.count, you are actually referring to the class variable, correct? So that the value of the class variable which is initialized to 0, you are incrementing it by 1 in the constructor. When is the constructor invoked? Constructor is invoked when you create an object. So if you want to keep track of how many objects have been created for this class, you can just maintain a variable like this, student.count plus equal to 1. So that 0 becomes 1 when you have created an object and the control comes into this constructor. And now if you have to create a class method, you have to use @class method as it is. @class method as it is from the syntax point of view. So this is called a decorator. Anything that starts with symbol in Python, that is called a decorator. So class method is a decorator. This is just a function only, don't worry. It is just def and then give some name to that. Here I call it as get count, and then remember this being a class method. If it is a instance method, what is that you pass as a very first argument? For example, display. Display was an instance method. What was that you have passed it to display as a first argument? It is always a cell. For the class methods, you should always pass, sorry, you should always pass class as first argument. So look at it. Instead of saying self, I'm just saying class CLS. CLS stands for class here. So CLS.count is what I have written. And then student.getCount. So look at this. On line number 10, you are accessing getCount. Okay. GetCount is a class method. You are calling that class method using class name itself. So This is perfectly fine. And class has access to the class variable, right? So it will be returning back 0 in this case. You have created two objects. Since you have created two objects, there will be two calls to the constructor, and in each call constructor will be just updating the value of the counter. So once you create these two objects in the memory, you can see the count being incremented to 2. Look at this. On the memory, you have seen count being incremented to 2. Then print student dot get count. See, again, you are calling that get count function using the class name, which is the best way or the right way to do instead of using object. Yes, you can use objects, but again, this will still give you the value, right? Any object you can use to access or invoke the class method. Okay, this also gives you the value properly because class variable belongs to each and every object of that class, right? So you can access them directly using objects also. Okay. So for class method, you should not pass self. Remember, self should be passed only for instance methods. And for class methods, you should pass a CLS. All right. Though you are able to access the class methods using the object names, this is not recommended, and Python doesn't recommend to use this notation while it is valid and it works well. You should always use class name to access the class variables. That is a summary. All right. What are static methods? So what is a class method? You have just seen, right? A class method is a method which is written inside the class, and what is that a class method can access? Class method can access class variables only. Okay. Now what is static method? Very similar, but when it is a static method, you have to use a decorator static method at the rate static method, and then remember a static method will not take self as first argument. Look at it. In this case, is age valid is a method. Okay, it doesn't take self. Just like a constructor, you see, constructor takes self as a first argument, right? But is age valid does not take self as its argument. So when it is a static method, don't pass self as an argument. When it is a class method, you should pass CLS as a first argument. When it is an instance method, you should pass self as first argument. These are the things that you need to always keep in mind, and these are the differences from how you have to operate with these different types of methods: class methods, static methods, and object methods or instance methods. Okay. All right. Now, how can I access these static methods? How can I call them? Right? Look at this example again. First of all, what is valid? Is valid? Is valid is a static method. How did I say that? Because it doesn't take the first, it's a first argument as a self. Okay. So it is not an instance method, but it is a it is a static method. Now I have created an object of class student, and it is S1. I have created one more object, it is S2. And now you look at how I am calling these static methods. What did I use to call static method? I have used the class name itself. Where did I use class name? I have used class name to access class variables. Not only class variables, but for static variables also or static methods also. To access them, you should use class name, which is more cleaner approach. Okay, well, so what is the scope of this is age valid? I said it is not an instance method. However, you can access it using class name, just like what you see here. And what is the benefit of this? Any generic functionality that you want to achieve, which is not related to any specific object, and you want to implement some logic or validation or such things, those things can be implemented as static methods. You see here, the is valid static method. What is the argument it takes? It takes age. It doesn't take self or class. Okay. So this age can be directly passed to this function when it is invoked, and that age can be of just a simple integer. Makes sense. So those are nothing but static methods where to define a static method in your class, you need to use a decoration at the rate static method, and then you define the method in the normal way. And when you are invoking it, you just use the class name dot notation, which is the most cleaner approach. The beauty of static methods is that you see here, you can see the static method call, how it is getting called using the class name. Class name dot static method is what you can see. Okay. And s1 dot, you can also call these static methods using objects. So s1 dot is yes valid. When you see that, you are passing s1 dot age. What is the data type of s1 dot age? It is nothing but a simple integer. It is an integer, right? So you pass an integer to this is age valid method. Okay. All right. Now you apply the same operation on s2 as well. Of course, this is also quite possible, and you can directly call it using class name also. Okay. All right. Let's move on. The accessibility part. This is very interesting. So far, we have been writing multiple attributes within the constructor, and they just come into play when you create an object. Correct? Now, from the accessibility point of view, Python uses a different approach than many other languages. What uses is it uses underscore notation. So look at this example now. Init is a constructor and self dot name is Ravi. Self dot age is a 6, and self dot marks is something 92. Okay, when you look at this, right, you have created an object just now. Okay, on line number 6, you have created an object s1 of type student. And if you look at s1 dot name, what is that you get? S1 dot name will give you Ravi. You did not pass name explicitly from the constructor on line number 6, but the code is already there within constructor to assign some default values to the attributes. So self dot name becomes Ravi, and self dot age becomes 6, and self dot marks becomes 92. All right. So when you print s1 dot underscore age, you see that underscore. So within this constructor, you have three members, three attributes. But what is the difference between each of them? Look at the first one carefully on line number 3, self dot name. Okay, name doesn't precede or followed by any other special characters, right? That is first thing. The second one, when you look at it, self dot underscore age. What is this underscore? Is it a typo or what? It's not really a typo, but it has a lot of meaning, and this is how the accessibility is controlled in Python. So self dot age, what does it really mean? self dot underscore age. There is a difference between self dot age and self dot underscore age. Self dot age indicates that it can be accessed from anywhere, meaning you need not just be only within the function in which you have written that statement, but you can come out of the statement and you can access it from anywhere. Whereas when you use underscore age, it has some special meaning. Okay, we'll come to that at a later point of time. But there is another thing that is self dot underscore underscore marks. Self dot underscore underscore marks. And it is initialized to some value at this point of time with 92 in the constructor. But when you have to update it or do something, how to achieve that is what we have to discuss. I'll show that as well. So look at this now. S1 dot underscore. First of all, let us go to line number 7. S1 dot age. It is accessible now. S1 dot age. Look at line number 7. Sorry, S1 dot name. S1 dot name can be accessed from line number 7 because it is just a plain attribute. When it comes to line number 8, S1 dot underscore age, there is a single underscore. So this won't be allowed to for access. We cannot access this. When you have two underscores, you cannot access it. Okay, but when you have single underscore, you can access. So all that you can access from this example is you can access name. You can also access S1 dot underscore age as well. So you'll be getting Ravi and 6, but you cannot access marks this way. Okay. So of course, if you have to really access something that is within the class or within the constructor, you got the attributes and it is underscore underscore and all. So what you can do is this is a special syntax actually. Yeah, the object name dot class name underscore underscore marks is what you need to write. However, you will be able to access, but this should not be practiced. It's not a best practice of coding, but still you can access it in emergency. So remember, whenever you look at an attribute which doesn't have underscores at the beginning or at the end, okay, that is treated as public, meaning that is accessible from anywhere. You need not just remain in that same function or something. You can also call it from outside. Okay, and when you have protected, how do you represent this protected piece? That single underscore is meant for that. When you have single underscore age, that behaves differently. But however, you can access it from the non-member function at this point of time. And when you look at line number 5, you have two underscores, self dot underscore underscore marks. Okay, when you have two underscores, that is not accessible outside of the method in which it is defined. Okay, so this is the visibility or the accessibility where what is what I can see from where I stand. Okay, so this is all about of course the underscore underscore which we'll call a name angled context. So how to deal with it is what I'm going to show you with some examples. Okay, so now let us come to discuss what is getter and what is a setter. You know what is a setter is, right? What is a setter? See, you have some instance variable inside your class. Okay, and yeah, you have some variable inside your class defined, but since your constructor, but now you want to access that value, the value of that attribute, or you want to just read. Sometimes you want to update it with some other value or and all that stuff, right? So how do you do that? For that, you have to use setters and getters. So this is quite simple. You might have done this already actually, right? When you have written something like this, you have a constructor, and this constructor takes only name as an argument. So you can just initialize, and also you look at it underscore underscore name. What does this mean? Okay, if you look at underscore underscore, it means that you cannot access it from outside this class, right? So so if you look at this set name is the one which can overwrite the existing name. That is how you are directly doing a simple assignment. No conditions, nothing. That's okay. That was intentionally written. Now, if you go to get name, okay, and look at it, it is a what is get name here? Get name is a instance method, right? And it takes no arguments, and it simply returns self dot underscore underscore name. Okay. So being in a double underscore variable, you cannot access it from outside the class. However, you can write some functions just like methods otherwise, like setters and getters, to store the value within that, also to access the value from that. Accessing the value from that is nothing but get name. Storing the values into that is nothing but set name. Okay. Now, once you create an object, you just use s1 dot get name. Okay. S1 dot get name. Get name is a method, right? So using this object of the same class, you can call the method. So get name is no problem. So this S1 dot get name evaluates to the method that you have implemented on line number 4. Okay. So the name would be what? It would be ROM. Then on line number 10, you have updated the value of that attribute, which is name. Okay. Because set name works on name. Okay. Now, under S1 object, the value becomes Ravi, and when you print S1 dot get name, you should see the value being printed as Ravi because you have just updated the value using this set name to Ravi. So the name of this object, the value stored in this object, right, that gets updated, and when you access it using S1, you will be seeing Ravi, not Ram anymore. Okay. So, but the thing is, what are the drawbacks of this approach, or what are the limitations, or is this convenient first of all or not? It is not convenient, right? Because what is the name of your attribute here? The name of the attribute is name underscore underscore name. Okay. You have asked for the method. You have asked for the attribute whose value, whose name precedes with two underscores. So when a variable value is preceded with two underscores, that cannot be accessed from outside the world. So on line number 8, 9, 10, 11, you cannot access it directly. For that, we have implemented setters and getters. Setter is to store some value or update the value or modify some value, right, in a variable. Getter is nothing but to get the value back. Okay. Next one is property. What is this property decorator? Okay. Look at this example. You have a class student and you have a constructor, and inside this constructor you have name, which is again preceded by two underscores. That means we cannot access it from outside of this class, right? So that is where, is it possible for me, instead of calling set name and get name, all those lengthy for syntaxes and all, is it possible for me to shortcut the name and use the very similar notation as s1 dot name equal to 10? That is how, sorry, name here, no, s1 dot name is equal to Ravi. Is it possible for me to update it that way? Similarly, if I have to access the value back, whenever I say s1 dot name, I should always get the name that is stored in that instead of calling s1 dot get name. So that is the objective here. Objective that you need to use property. So when you use property, What you can do is, what benefit you will get is, this is syntax is what you get benefit on line number 11 and 12. If you don't have this property, what you need to do, you need to call the corresponding setter and corresponding getter by your on your own. Okay. So look at line number 11 now. Print s1 dot name. When you say s1 dot name, what happens? Since you have defined a property decorator, you see the property decorator there on line number 4. Hence, s1 dot name, that syntax, okay, refers to the name attribute of um, the object s1. This is more convenient. You need not write that entire method name, right? It is a normal scenario, a normal syntax. X is equal to 10. Similarly, you are just now getting the value of the value s1 dot name directly without using the function notation like get name and all. Similarly, you look at line number 12. Line number 12 will be giving you an error. Why? Name is not a function anymore. You see this line number 5 as a function, name is a function, but you cannot call it using the object. Okay. Now I'll just practice. I'll just write this and I'll just show you what happens because how property works is what you need to really understand. Okay. So earlier, what were the getters and setters? Forget about this. Now we don't need this. And if you have getters and setters, whatever you do in the constructor, almost same in the setter also. So what you did earlier, you have used set name age or something. Okay, you have to take self, you have to take name, you have to take age, and then you directly assign these incoming values to this. Okay, now getter. You can write get name and this getter, so no need to pass any arguments. Here directly you can return self dot name. Okay. Similarly, you need to write get age. Okay, and then you have to return back from here. What is it you need to return? You just need to return self dot age. All right. So to store the value, you use setters, and to retrieve the value, you use getters. And whatever you want, you can now invoke from here. You create an object, and then you can call the respective function or the method, right? Student dot. Okay, forget about this. We don't need this now. It is for class variable. All right. Now, while creating an object, what is what I need to pass? I need to pass name and age. So I pass some name here and I pass some age here, right? Now I can update the value of yes. How to do that? I can call set. Set what? Name and age. And what does it take as arguments? Name and age is what you need to pass. So say for example, I want to change, I have to update the name like this, and I also have to update the age like this. Okay. So the after you execute this piece of code, after this you execute this code on the line, on this line, Abhi will be replaced with Bhuvana, and age will be age 6 will be replaced with 7. That is nothing but update operation. Okay, setter basically. You are using setter to update the values, right? And what is a getter actually? Say for example, you want to get the name, you want to know the name. For that, you can directly use. Let me print the name otherwise. Yes dot age. Similarly, the other attribute is name. So if you want to get the name, you can use yes dot name. These are the setters and getters, right? Using these, you can manipulate the using setter, you can manipulate the data. Using getter, you can retrieve the data. That is what we have been discussing. Okay, but instead of oh sorry, this should be yes dot get age. The name of the function is get age, and here it is get name. Yes. Instead of writing all these lengthy names, like whenever I want to update, I should use yes dot set name age or whatever. And similarly, when you have to get it, you have to call this. Instead of that, is it possible? It would be more convenient for me if I can write the statement like if I have to get the age, I can just say yes dot age as simple. If I am able to do this and still retrieve the age, that would be helpful to me, right? That's what the expectation is from the developers, Python developers. So s dot name. By just writing it as s dot name, I should get the name. Okay, using the getter, I should get the value, but the notation, the name, how I write it should be different. That is the thought process. So for that, what is that you need to do? You need to use decorator. Okay. So go back. So you need to use this decorate property. So I'm also using decorator property now. Give me a second. And property is I'm going to decorate. First we'll do it with get. So right at the rate property. Okay. Once I define like this, I need to use keep this as setter asset for now. Or let me bring this to get path. All right. Now if it is for name, I would like to call it as name only. Property name, and this is just simply written self dot. What is it you really have here? Okay. Um, if it is hidden like this, you can just return self dot underscore name. Makes sense because in the constructor it has been you defined by using two underscores from the visibility point of view. So you have to use self dot name. Okay. So now this directly yes dot name will directly work. You need not use at all the function notation get name or whatever it is. This would directly work. Yes dot name should give you the value. Okay. So, sorry, let me remove these things. Student takes no arguments. Okay. Student, what is in it? Student, where which line? It takes arguments, right? This is a class, this is a constructor, and you have passed two arguments. Why is it saying it doesn't? Student takes no arguments. Capital letter only. Line number 18. Okay. Mm, Set name is you pass self, you need a name and you need age. Set name age, okay, and yeah, whatever you pass, it should update. No, what is there? Which line? Line number 18. I define this as a property, and then I just directly return name here, which is available. No, yeah, it is available. Self dot underscore name. It is a different one. Why is this throwing error? Yes, okay. When I'm creating an object, yes, it takes no arguments, is what it is saying. How is init initialized? How init has values, no? Oh, sorry. It has an wrong name. Student object has no attribute get name. Okay, so let's go back. Yes. So since you have changed the name here, you have changed it as an attribute, this is not going to work. So all that you need to do is you just need to use the normal notation get name and not function call. This is what I was showing you on the slide. So just run this now. See, you get 7 and you get Bhuvana, right? So this 7 is coming from get age still and s dot name. In fact, there is no any attribute by just the name. You have something called underscore name, but you don't have name. But because of this property definition in your class, now it allows you to directly use the notation, the older notation, which is s dot name or whatever, and you should be able to access all the values just seamlessly. So this is how the properties, and this is a getter property because you have just written this for getting the values. How did I know if it is getting the values? Because of return. Return will always get the value, right? So this is a setter property. Similarly, how do you you have to define the get setter property? To define the setter property, you have to again write one more decorator. So that is what I'm going to cover first. Hope you understand this, right? The last one has will be giving you the error that I have already shown you just now. Okay, now since you have the get property, now you have to define the set property. To define the set property, you need to use this decorator again. So the name at the rate name is the um, setter, right? It's the name of the setter. Sorry, it's the name of the getter actually. You see that on line number 5. So that line number 5, whatever name you have used, you have to use at the rate that name dot setter is what you need to use the decorator. That is how you have to write as it is. Okay, and then since it is a setter, you need to pass the value. Okay, so once the value has been passed, you are going to store it in underscore name. That is what you, so that you won't be able to access it without any such functions available. So self dot underscore name is equal to age. Now you create an object on line number 10 and then try to update the name. Okay, so look at this carefully. The syntax that you have written is you are not really calling s1 dot set name or any such functions. You are directly using the notation of just x is equal to 10 like that. Basic data type notations only. So s dot name is equal to Ravi. Automatically, internally, the corresponding setter will be invoked. And s1 dot name, when you print it now, you can see Ravi coming out. All right. So this is how, and keep this in mind that we can really the setters are really helpful to make any validations in the code before you store the value in the attribute. Okay, look at this example. So what I'm doing here is I'm just checking whether the length of the incoming value, which is to be stored in a name, is having at least one character, and it is also not exceeding 30 characters is what I am first ensuring. And only when that is satisfied, then I'm going to update the name with the incoming value. Otherwise, I'm going to throw out an error, or error or some message is what you can write. So now you may get a question, if the object is already existing and that object has some value in its corresponding attribute, in this example name, okay, and then this such conditions got violated in the setters, then what would happen? What would happen is the old value will still retain, that won't be damaged or that would not be overwritten. Okay, so that is what we are working on. And sorry, the old value will not be lost, but when the condition is false, then it comes to else block and it will give you that indication, it will print that message that invalid name and so on and so forth. Okay, so this is how you can use property. And now let me also complete writing the setter for the thing, for the one that we have been writing there. Yeah, here name, oh, sorry, name dot setter. Now, and remember, the name of this property and this setter would be one and the same now. Okay, and what is it you need to do? For now, I'm just directly assigning, but you need to pass the value also because it is a setter. What to set is what you need to pass, that for comes under that comes into value, and then sorry, um, self dot underscore name is equal to value. I am not doing any checks here, but we can do checks really. I'm just trying to complete this. And if I am able to do this, how can I update the name, or how can I set the name? I'm not going to use such functions now, right? It should make it simple, right? So s dot name is equal to, I just change this, and I don't give the age so that it will automatically assume. And then instead of get age, okay, keep the age aside because we did not write any method for that. I have only dealt with name only so far, so let it be. Now s dot name is equal to, sorry, no braces. Okay, you see it got changed, but what is the notation I have used here? Keep that in mind, that is important. So just like as if there is no any function for this, it pretends that it is just a normal variable, but to be honest, this is not a normal variable. This is some variable where you cannot have the access outside this class, but still using this property setters and getters, you are able to access it, and you are also able to change its value. All right, next let's move on to the next topics. Very important. This is what I want to practically show you. For example, while writing such property, this is very important. If we just write it as self dot underscore name, that is how it has to be written, and that makes sense. But if you miss this, okay, then what happens? Let me show you. What happens is it repeatedly keeps on substituting, but it never gets the end. So it gives you maximum recursion depth expected. So this is a recursion error. This is the kind of error that you see here. So we should be very careful while implementing the property. You should use that same visibility that you had in your constructor. Okay. All right. So be careful about this. These are the common mistake that you do. Okay. So you should use underscore. Okay. And of course, I did not show you the validation, but it's a small thing. You can also try putting the validation and all inside that. Okay. All right. The next topic is inheritance. What is inheritance? As you see here, it is just another concept in the object oriented programming where the class will get some attributes or the methods from already available class. Okay. It's nothing but borrowing something from a different class. Okay. So let us look at an example. There are different types of inheritances. One is single inheritance. In this single inheritance, what you can see is you can see two classes. One acts as a parent class and the other one acts as a child class, and that's all. There will be only two classes here. Okay, and if you look at this example, you have two classes. One is animal and the second one is a dog. And a dog is a class that has been inherited from animal, is what we say. So in the brackets of dog, you write animal, no? So it indicates what is the parent class of this dog class. So here there is some terminology that you need to understand. Whenever there are multiple classes that you have been looking at, right? But um, in this single inheritance, what happens is there will be two classes only, and there will be one parent class and one child class. Okay, or one base class and the other one derived class is what people also call it. But parent class and child class is are the better terminology to use here. So class animal, it is just a standalone class and it has a method called sound. And if you create an object of animal class and if you call that object dot sound, it will print animal makes a sound. And now when you look at the second class, which is class dog, which is inherited from animal. How can I say that it has been inherited from animal? Because in the brackets you see animal class name written there. Okay, perfect. But it doesn't have anything. You see pass there. That means that there is no implementation of this dog, but still the class only empty class is present. Now what happens? So for example, if I create an object of type dog, have created an object of type dog. Okay. Now using that object, if I call sound, first of all, don't you think it is an error? In fact, in inheritance, it's not an error because this is how the attributes and the methods will be shared and reused. Okay, in the inheritance. So my pet dot sound. In reality, sound is a method which is available only in the class animal. However, dog is a class which has been inherited from animal class. Dog will automatically get the sound method. Okay. So here in this example, animal is a parent class and a dog is a child class. Okay. So if you want me to quickly show this, I can do that. So I can just create some quick, I call it as space. Okay. And I just write some function. Next, I'm going to write one more class. I call it as derived or something. And within the brackets, you just write as base here, which means that derived class, this class is being has been derived from class base. And I don't want to write anything within this class for now. I'm going to create an object of derived for this derived class. So sorry, derived. I'm going to create an object. So I'll say object is equal to derived. Object is equal to, oh sorry, object is equal to derived. Well, now, okay. Now using this obj, I'm going to call fun and see what happens. So as you can see here, this is inherited. This derived is inherited from base class, and base class has fun. This would be executed now. That message you can see. Fun takes 0%. Did I pass any arguments? Sorry, I did not use self. This is instance method. No. All right. Yeah, you see. So what happened here? Function is in one class, but the one who made use of it is a different class, right? Who called it is a different class, really, right? So when a method is in base class object only should be able to call it, but that's not the case here. Derived class object is able to call the base class method, right? So in this example, you have one base class and one derived class, and this is what single inheritance means. Next one is multiple inheritance, where you have multiple classes and there is a chain of inheritance basically. Like when you say father is a class, assume, and it has a method called skill one, and you have mother, which is an independent class to father. Okay, and it has a different method, of course. Okay, skill two. Now, child. When it comes to child, it has multiple parents. Like it's not only father, but it will also have mother. This is a concept. So child will inherit from more than one parent. That's the thing. And in a single inheritance, child will only inherit from single parent. So here Tony is equal to child. That means you have created an object by name Tony and Tony dot skill one. What will you get now? Will throw an error? No, because it is inheritance. Look at it carefully. Father is a standalone class. Mother is also standalone class. But when it comes to child is a class which has been inherited from two different classes, father and mother. Okay. So what happens here is this child will get both the methods into it, which is skill one and skill two. So now using Tony dot notation, you can use call skill one where you will be getting father driving, and you can also call skill two where you will be getting mother cooking. Makes sense? So this is how multiple inheritance work, where you will be deriving from multiple classes. Okay, that means you will be having one child class, and that child class can have more than one parent class. The next one is multi-level inheritance, which is generally used for hierarchical representation. So if you look at this, no, this is a family chart kind of thing. So you have grandparent, and there is a house. Okay, house is a method, and it's a instance method basically, and it just prints own a house. Oh, sorry, owns a house. And from grandparent, you will be getting your parent. So you have something called parent, and it has been inherited from grandparent. But I don't want to write any code within that. Okay, but I have implemented one more class, child. Okay, which has been inherited from parent, right? And the body is empty here as well. Now I create an object. Object to what? I have created an object to child. Okay, the class which is at the very bottom level of the hierarchy of the inheritance now, right? Now, if you just print Tony.rs, okay, what is that you get? Sorry, Tony.house. So, if you look at, first of all, Tony belongs to which class? Child class. Inside this child class, do you have a method by name house? Not really directly. You did not implement anything. Okay, fine. In that case, what happens? It will get the access of the parent class. That's what I'm going to show you now. Okay, animal is a very generic class where you have just written something animal makes a sound, but what sound, all that we don't know. And similarly, you have two objects created, one object for dog and the second object for cat. Okay, now when you say my pet one dot sound, okay, my pet one belongs to dog class. So inside the dog class, Python checks whether there is any method by name sound. It did not find it now. Then what it will do? It will check for its parent, which is nothing but animal. So inside the animal, is there any method by name sound? Yes, it finds it there, and that is what it prints. Animal makes a sound. Similarly, when it is my pet two dot sound, that means cat, right? So it checks in the class cat whether there is any method by name sound. It's not there. Then it goes and checks in its parent. So the parent of cat is animal. Again, it's the same parent, and that is where it goes and fetches the data. So my pet one dot sound will finally represent what? Animal makes a sound. My pet two dot sound also gives the same response as animal makes a sound. Okay, in this example. Now, hybrid inheritance is nothing but it is a combination of two or more inheritances that we have spoken or looked at so far, which is single inheritance, multiple inheritance, and multi-level inheritance. At least two of these two have combined, then it would become hybrid inheritance. So, just for indication, I have written some class, and I am deriving B class from A. I am also deriving another class C from A. Okay. Now, when it comes to class D, it has been derived from two base classes B and C. Okay. Now, if you create an object of type D and if you call sound, which method will be invoked? To understand this, there is something called um, MRO, method resolution ordering. I'll cover that. But there can also be situations where this is called a method overriding. So in the base class, we have some method with some name, and in the derived class also, you have a method with the same name, but the body is different, the implementation is different. That's called method overriding. Okay, and see in this case also, you see, you have class B inherited from A, class C also inherited from A, but from both B and C, you have the class inherited. You have class D inherited from both B and C, and you have sound method in two classes A and B. Now if you create an object of D and if you call sound method, which should be invoked, whether it should be invoking from A or B or none of them. Okay, so in this for this only you have MRO, which is nothing but method resolution order. And look at this carefully. You have same example, I'm just showing you A and B, and then C, and you have D. D has been inherited from B and C. In this case, you look at this output statement, right? D is a class name. Class name dot MRO. What it really gives you is it gives you the order of the resolution or order of lookup for methods to be executed. I'll just show you quickly. So let us still have this. I'll just call it as A, and I have fun, and I am in fun. A, I will say. Yeah, and then derived, instead of derived, I'll call it as B, which is inherited from A. And here also you put the same code. I just edit it only in B, but the function name and everything is one and the same. Now I have another class C also derived from A. I have another class also derived from A, and this also has inherit overridden function overridden. Function overriding means the base class method has been redefined with a different implementation or something like that. Okay, now coming to D, class D, which has been inherited from both B and C. Okay, which has been inherited from both B and C. Now, here also I don't want to write anything for now. Okay, of course, if you want I can override, I'll show you the things. If you have just created an object of type D, and if you call obj.fun, which one would be called? Whether it would be called from C or B or A? That's a question, right? For that, to understand that, no. So, okay, first of all, let me run this. What? Oh, sorry, there is no indentation. Sorry about that. Also, no indentation. Okay, see, it has called the method from B. Why and all, how to know that, I'm going to show you now. So what you can do is you can just print the class name, which is D dot MRO. You can call this method MRO, and in this, sorry, and this. You see here what it returns. It says that, see, in such situations, I'll be first looking at class D is what it is saying under the main module. If I don't find it there, then I will look at B is what it is saying. If I don't find it in B also, then I will be looking at in C is what it is saying. If I don't find it here also, then I will look at A is what it is saying. So this helps us to understand what is a hierarchy or the what is the order in which Python looks for method resolution. When I say method resolution, the same method will be implemented in multiple derived classes, and which one to use is a confusion. So in such cases, you use MRO, you print MRO and you will get it. And interestingly, for this, you see here, and you understood, right? And what if I have the same function in D also? What would happen? Can you guess now? Because if you look at that ordering, right? Look at the previous output, you will understand. What it says is, see, first I will check in D only, it is saying. Now I have made it available in D. Earlier, this method was not in D, but I have just added it now. Okay, just to be consistent on these things. Okay, now run this. You see, it does. Okay, sorry, I did not change the thing here. Hmm. Now you will understand. Okay, see, it has come from D only. Why? Because the very first thing that it checks is in class D only, and in class D, I made that method available. So it has just executed that as it is. If I don't make it available in D, say for example, this is not there, this is pass, for example, then what would happen? Look at the such a hierarchy. It says that then I will check in B. Okay, in B it is there. Right now it is present in B. So you will be getting this B now. So if you run this now, you'll understand that you will see that it will be getting it from B. So you got this message from B only, right? That is how that hierarchy helps us. And if you remove from B, then it will look for A. That is how it is. Okay, now I'll slightly change this. The order in which I mentioned the parent classes is what I'm changing. And now run this, just run this. Oh, what mistake I did. Oh, sorry, it is C and B actually. B. Okay, now run this. You see here, it says that first I'll check it in D, then I will check it in C, not B. Earlier it was a D, after that it is B immediately. But now it says I'll first check in myself. If I don't find it, I'll get in C, not B actually. Then if I don't find it in C also, I'll go to B. So it all depends on the order in which you have specified the class names here. This is very important. So this is how the method resolution will take place. And there is another method to print the MRO. This is another method where D dot underscore underscore MRO underscore underscore. I'm going to show that as well quickly. It is just print D dot underscore underscore MRO underscore. Oh, sorry. Hmm. You see, you can see both the output being same, but of course, the first one is a list and the second one is a tuple. That's the only difference. Okay, but the content would be one and the same. D, the ordering D, C, B, A, and then object. All right. So this is what this MRO tells us in what order the methods will be resolved. Okay, look at this carefully. Of course, the same thing I have just shown you just now. So this is just practical. I just changed the order, right? I have shown that already. Forget about this. Now, yeah, what is super? Okay, so this is helpful in inheritance. So look at this. You have a class called person, and it has a constructor, and it takes name. So this person class has one object, one attribute, name. Then you have student class, which has been inherited from person class. Now, when you write the constructor of this derived class student, how do you write that? Okay, because when you are going to create a student, you need to not only pass name, but you should also pass the roll number, correct? Based on the arguments to this constructor now. But name is taken care by person or the parent class, and roll number is what will be taken care by student class. That is one way of thinking of it, right? Because base class already has name as its one of the arguments to the constructor, right? So you see this super dot init. So super, what is that actually? It is a built-in function. What it will do, it will just create a dummy object of type parent, and it will just give it to you so that you can make calls to the parent. Okay, so here super dot init. So you are really calling the init method of parent class, which is person class. Okay, then self dot roll is equal to roll. Whatever roll number you pass, I'll just put in roll number. That's all. Quite simple. And if you want to display a function, if you have to implement display function, you can also do that. Of course, you can print the name and whatever self dot. It is again mm, quite what kind of function this display is. Display is What is the display? Display is instance method. So you have to pass self. Okay. All right. Now you look at S1. You create student one with RAM and 101 as arguments to the constructor, and you print S1 dot display. So what will happen now? So automatically, when you have created this S1 in the memory, or when you have defined this S1 in your program, what happens is the constructor would be invoked, but the order in which these constructors are invoked again depends on that same MRO method I have shown you. But again, always these constructors will be first getting the parent constructors called, and if it is again multi-level inheritance, that might be calling a different parent. So that is how it first goes, and it will initialize that in the reverse order, and then finally it will come to the current object, and it will initialize the values. All right, that is how super works. A simple example here, and you have class variable also using super. I have shown you how to access the methods, because earlier you have seen how to call init of the parent. Okay, you can also use the super to access the attributes directly. In this case, I'm using super to access the class variable. And how to do that? Look at this line number 10. Okay, so first of all, understand this code. Class person, and inside that class person, you have species is equal to human, means that it is a class variable. Next, init the constructor of person class. Then you have student, which has been derived from person, and you have a constructor there again. And you have already used super dot init, meaning you are already in the student class, but you are calling the parent class's constructor. That is where you are using super dot init, and you are passing the same name that has been passed as an argument to constructor student, right? Then you are left with role. That roll number you need to only have to deal with, because the parent person doesn't know the roll number and all. So inside this student class, you can take care of dealing with roll number. So self dot role is equal to role, and then display. Display is quite common, self and then normal thing only. It is how you have been using it. But look at this display. You are using super dot species. That means using this super function, you can either call the class variables, or you can also call the methods and all that of the parent class. Okay, so if you look at line number 11 now, you have created an object of type student. Okay, because the student is the one which is at the bottom of the hierarchy almost, right? At the bottom of the hierarchy. So you can create, whenever you are creating objects, you have to create them to the of type very last derived class in general. That's what we do, right? So that you'll get all the functionality of all the parent classes into it inherited. Okay, now s1 dot display. So when you say s1 dot display, you are just going to display function of s1. So self will be s1 at that point of time. Name, and name will be coming as ram, and then roll number will be coming as 101 if it has passed the values that I have mentioned here. All right. The next one is method overriding. Method overriding I have just already discussed in a different context, but it is very simple. So when two classes have, and they have been having some inheritance relationship. In this case, animal is the base class and dog is a derived class. So both of them can have the same method, but the implementations can be different. Okay. So this is nothing but a method overriding, because if you look at animal class, you have sound method, and you also have sound method in dog also, but the implementation is different. Okay. So just if you have to create an object of type animal, you can say something is equal to animal. Okay, and if you call sound from ani, what happens? Which sound method will be called? Animal classes one, or dog classes? It would be calling the animal classes one, because Annie is a variable of type animal, or Annie is the object of type animal. So anything that you use any dot, it will always go to the animal only. Similarly, when it is my pet is equal to dog, my pet is the object of dog class. So my pet sound, sorry, when you say my pet sound, sorry, second. Yeah, when you say my pet sound, my pet belongs to, my pet is an object that belongs to dog class. So the method by name sound within the dog class will be invoked here. Okay, so this is what we call method overriding, and polymorphism is very close to this concept. So again, it's the same thing where you have a class animal and sound method inside it, and you also have dog, which is inherited from animal, and the same sound method has been overridden here. Okay, and you have a cat. Cat is another animal inherited from animal only, and you can also print some message here. And look at this. This is what polymorphism is. Polymorphism is many forms, right? So you can use for loop like this. Whenever you have such inheritance and you have some um, classes derived this way, right? I'm just what I'm writing here is for animal in what dog. Dog brackets means what? It returns an anonymous object back of type dog. Cat, same story. Okay, I have used cat twice intentionally, and again dog. And what is that I can do now if I have all these objects in my plate, right? If I have to do some method calling, how these method calls will happen? When I say dog, first time what will come into animal, the dog object will come. So in that case, when you are calling that animal dot sound, what would be called? It will be called from the dog class, right? And when you iterate, because for is iteration, right? It is iterative structure. When it comes to cat, what happens? Cat dot sound. So inside the cat function, or sorry, class, cat class, whatever the sound method is, that would be invoked. That is how at runtime, okay, at runtime, the method resolution will take place, and accordingly those things will be executed. All right, the next one is abstraction. Abstraction is again it's nothing but hiding and not showing unnecessary um, or non-important details exposing to the end user. That's what abstraction means. So if you have to implement abstraction, you have to import this from ABC. Just import ABC lowercase and also the abstract method. Okay, these are the things that you need. And then say for example, shape is a class, and if you have written ABC, what is ABC here? ABC is another class. Okay, that is for abstraction related libraries and all. Sorry, abstraction related code and all that will be there. And you see here, you have this shape class has area. Area is a method, right? But there is no code inside that. And you have a circle which has been inherited from shape, and here you have init to initialize, and you also have area of this circle. Okay, how you have computed the area of the circle by 2 times sorry pi r square, so pi times radius. And now when you create an object of shape, which means the base class um, variable type, then that became plate, and that gives you an error if you are directly going to call area on that. The second syntax, so you have to get rid of line number 10 totally to make your program work. So on line number 11, what you have done, you have created object of type class, which is a derived class. Why can't you create an object of shape? Can you any guess? Because it is abstract class. Meaning, if you look at the code that you see here, okay, and you cannot create any object of abstract classes. Why? Because abstract classes are incomplete one way, incomplete instance from the development point of view, or abstract classes are the classes where implementations are missing. For example, in this example of shape class, the area, how to compute the area that the data is missing, right? Line number 3. Because line number 4 you have pass. That means the actual implementation of the area has not been implemented. Why? Probably because to compute the area, you need to understand what type of um, object it is, whether it is a rectangle, whether it is a triangle, whether it is a circle, all that. So it is too early to compute the area within class shape. Now, when it comes to circle, yes, circle is more specific class. In the inheritance hierarchy, shape is more generic, and circle is specific or less generic, we say. Okay, because we know the context and we also to know that it is a circle only. So you have computed the area since you know the circle and you now know the formula, right? And so whenever you have abstract class, you cannot instantiate that. That means you cannot create object to that class. Okay, now assume that line number 10 is commented out. Then come to line number 11. What did we do? We have just uh, created one more object of type circle and you have assigned it to plate. Okay, and then if you ask for plate dot area, it will directly go to the area implementation of circle, and that is what it computes and prints. All right, the last topic for today, that is special or I don't know how you pronounce this, dunder method or whatever. Actually, it refers to d under, which is a double underscore methods. Okay, so these are the special methods that are available, and especially you have a class and that there is an inheritance involved in that. These things would be really helpful, and I'll show you some of them. So look at this a simple example. You have a student class and it has a constructor. Well, so far no problem. And have created an object to this student class, right? And name becomes Ram and age becomes 5. That is how you will store this. Now second object also has been created. Okay. Now when you print S1, what will happen? When you print S1, see, I directly use print and I pass object. What would happen in this case? So let me have the same thing and I will just remove all this. Okay, we have one. I create an object of class A and I'll call it a small a is equal to a. Okay, now I print run this. You see, it has given you some message like this. I run it again. Okay, you see, this time it got a different value. But anyways, this is how it is just returning you something. It will return you something, right? Each time you call it, you may get a different result. Okay, now that means when I'm trying to print the content of an object, this is not working well. Okay, say you have some constructor here, so that we'll be getting the attributes. Okay, say name and age. self name age, self dot name username, self dot age is age. Okay. So say for example, I want to print the values of these attributes, name and age, but this is not going to help us. Again, name and age, where is the mistake? Self dot age dot name age. One. Okay, we got it. I did not pass the arguments why I'm creating the constructor. Okay, you see, you get some output, but it never says that I'm running this one more time just to show you the difference, different things coming up, but it never prints the values of this Ram or Raju or whatever it is, right? Okay, fine. But same thing, if you have two different objects and you are trying with both, again, you will be getting that kind of message only, but you will not really see the attributes printed. For that only these dunder functions will help. There are some specific functions that are available for handling such things. So let us take this same example of class. Okay, and you see underscore underscore str underscore underscore. These are the double underscore methods. Okay, it means double underscore is there at the beginning, double underscore is also at the end. That's why these are called dunder methods. And there are a good number of methods like this. In it is the best example. The constructor have been writing from a long time. So whenever you have a constructor inside a class, it is nothing but a dunder method. Okay, these dunder methods will be automatically invoked by Python. That is a specialty of this. So you see, you don't call the constructor automatically. Sorry, you don't call a constructor explicitly most of the times. It will be called automatically by Python. No, okay, but only when there is inheritance, you will be using super dot and all that method implementation. That's a different story. But there are very rare chances that a developer will take care of all invoking all these things. So in such situations, these built-in functions will help us. So when you so each of these functions have their own meaning and also application. So underscore underscore init underscore underscore, you know what it does. Okay, that is used as a constructor and that helps in constructing or initializing the objects. And there is one more thing underscore underscore str underscore underscore. So what this does is it is used in printing for printing purpose. So as you have been getting the error, right? So what you can now do is you can go back to your program and you can just add that function def, okay, underscore underscore str underscore underscore self. Okay, you see, and then you just return the string. How do you return that? I'll show you. You have to pass it as a you have to return it as a formatted string. So f over there and self dot, what is it you have here? You have name, right? Self dot name comma, this is just a notation. Self dot, this is how I want to see the out page. All right, close the single quotes. Now you print here. Okay, you see you got Raju comma 20. This is very much different than the earlier response, correct? So this is what you have customized. How is this possible? Because of those double underscore functions. Those are random functions. So All that you have done is I have just defined this how I want it to be. That is what I want to find. And for example, you can write your own logic, your own pattern here. What I said is just give me a formatted string where give me the name first, put a comma, and then give me the age for whatever I pass. So for this, whatever I pass, this is what I have got. But again, this is how these things work. Yeah. There are other examples as well where you can check the equality of two objects. For that, underscore underscore eq is there. That also I will be covering quickly. So eq is this. So you will just simply check if the current object is same as exactly same as the other object. Other means second object that you are going to pass. So if you have to look at the entire code, this is what it would be. Okay. S1 equal to S2. Then underscore underscore EQ underscore underscore would be invoked. And when you have written S1 S2 equal to S1, then also the same EQ um, method would be invoked or run will be invoked. All right. This brings us to the end of the session. Before I conclude the session, I would walk you through. Sorry. The technology website for those who have joined late. So this is our website where you can look at the courses that we offer, and if you want to contact us, there are different means available. And under resources, you can download all the resources that we have been using for our live sessions. Okay, and you can download them for free and you can make use of them. You can practice those and become better programmer. Also, on the YouTube, we have YouTube channel where I strongly suggest you to subscribe to that so that we'll be getting daily links, daily quizzes. So here, if you look at these are the daily quizzes that are available that will be posted on a daily basis on Python, and these are just cards less than half minute, so you can watch those things too till the end and guess the answer, and you can validate whether your guessed answer is right or wrong. Okay, this helps you to be in touch with the topics or the concepts. All right. So I strongly suggest you to subscribe to this our YouTube channel and be connected with us. With that said, I will conclude today's session and take care. Bye.